Okay. Yeah, we welcome you back again to part 2 of this question on photoelectric effect. Don't forget that the channel is Physical Sciences Silver Bullet, and the name behind the channel is Richard. We would urge you to subscribe, urge a friend to subscribe, spread the gospel. We want to remind you that our goals are very, very direct: to make this channel the biggest in this industry, to help learners who would feel that physical sciences is hard and is a stumbling block to their career. So we thank you, but we also urge you to spread the gospel. So let us look at the question here. It's a continuation of part 1, 1.7. The question says that ultraviolet light is incident on the surface of sodium metal. The threshold frequency, F naught, for sodium metal is given, that one. And the maximum speed of an emitted electron from the metal surface is also given. Then the question says, the first one, what is meant by the term threshold frequency? So what is a threshold frequency? This is the minimum frequency of the incident radiation required to cause photoelectric effect, or required to cause emission of electrons from a metal surface. So that's it. The minimum you would need to make the metal start losing electron is what we call threshold or cutoff frequency. So that is that. Now we go to the next question. So we are having another question on the same setup. The question says that a learner doing the experiment decided to use X-ray instead of ultraviolet light. The question says, state whether the ammeter will give a reading or not. To answer this question, you need to borrow some information from somewhere. You need to know the electromagnetic spectrum. This is the spectrum. It's in the spectrum. We have the arrow indicating frequency, and the opposite arrow will indicate change in wavelength. So from the spectrum, you can see that of the 7 radiations, radio has the lowest frequency and the gamma has the highest frequency. And you need to recall that frequency somehow has an effect on the energy from the equation, which is E is equal to HF. So in other words, when you look at this expression, it shows you that energy of any radiation is proportional to frequency. So, and remember, for the ammeter to give a reading, the frequency of the incident radiation must be greater than the work function of the metal. So now, when you look at this scenario, we have ultraviolet. It gave the ammeter reading already. So what the change is to X-ray, which is having even a higher frequency than ultraviolet. So what the spectrum I'm trying to explain here is that X-ray and gamma rays will obviously give a meter reading because their frequencies are higher than the ultraviolet, which already gave the reading. So, which means that X-ray has a higher energy than gamma. Sorry, X-ray has a higher energy than ultraviolet, and gamma has a higher energy than ultraviolet. So both these ones will give what? A reading is obvious. So the answer is yes. Then comes the next question on this aspect. It says, explain your answer in 1.7.2.1. So the answer is yes. What does this imply? That the X-ray will give a meter reading. So what is your reason for that? The reason is simple, that X-ray has a higher frequency, and which implies it has a higher energy. So being with a higher energy than ultraviolet, it will obviously give a reading. That's the answer. So that is the answer to this follow-up question on this aspect. So let us now go to another question on this very setup. Okay, then comes this question. Using the same draft of the question, we are coming to 1.73. And the question, the statement says, a learner doing the experiment decided to use X-ray instead of ultraviolet. And the question says, state the effect this change will have on the ammeter reading. So what effect will this change have on ammeter reading? You have to know that yes, we are sure that X-ray is going to give ammeter reading. Its frequency is higher than ultraviolet. But now, changing from ultraviolet to X-ray, what effect does that have on the ammeter reading? Remember, ammeter reading reads current, and current means number of charge flowing per unit time, and that can only be changed when you change frequency, not when you change. That can only be changed when you change intensity. Sorry, not when you change frequency. The change from ultraviolet to X-ray is a change in frequency when you go to the spectrum, electromagnetic spectrum. So we are increasing frequency. What does the increase in frequency has? What effect does it have on the current? There is no effect, because the number of electrons flowing per unit charge remains unchanged. A number of electrons flowing per unit charge is the current. So the answer is no effect or no change. Then comes this follow-up question. It says, remember, it comes from the statement, substituting ultraviolet with X-ray. Yeah, and the question is, what is the effect on maximum kinetic energy of the emitted electrons? Now, to answer this question, you need this information. We'll write the answer later. You need to. The information says that E, being the energy of the incident radiation, and work function comes here, and then you have EK. So when you change this one to suit our situation, we are changing frequency. You understand me? And this one, we are going to leave it like that one because this one is a characteristic of the metal, so it remains unchanged. And we are talking about maximum kinetic energy, so that one is also there. Now, we need to know this. We need to know that a change from ultraviolet to X-ray changes frequency, and it increases it. So when the frequency increases, now we need to look at this. The work function is constant, it's the same metal. So every increase we see here, it goes to increase the kinetic energy. So the answer is going to be increase. The maximum kinetic energy of the electrons will increase. Okay, then comes the last follow-up of this video on this part. The question says, effect on the number of electrons emitted per second. Remember, you have to remember that the cause or the change is substituting ultraviolet with X-ray. We are taking out ultraviolet, replacing it with X-ray. And we found from the spectrum that X-ray has higher frequency. So the change we are demonstrating here is change in frequency. So the question is, if you change frequency, what is the effect on the number of electrons emitted per second? Like I told you before, anything, the factor which influences or which changes number of electrons emitted per second is intensity. Because the intensity represents number of electrons striking the metal surface per unit time, which represents number of electrons emitted per unit time. So that is it. So what is going to be the change in number of electrons per unit time if intensity remains constant and frequency changes? The answer is no effect. Actually, you have to remember that whenever this question comes, number of electrons per second, it's the same as ammeter reading because electrons per unit time is the same as charge per second flowing. So the answer, no wonder the answer is the same. The answer is no effect or no change. So on that basis, we are going to close this video and make it part 2. Yeah, but as we are winding up, I need you to remember this for your understanding, that if you want to change number of electrons emitted per unit time, or the ammeter reading, or the charge flowing per unit time, all you have to change is intensity. So intensity affects number of electrons emitted per unit time. It affects the ammeter reading. If you want to change the energy of emitted electrons, the change should be frequency. Frequency affects the energy of incident radiation and eventually affects the kinetic energy of the emitted electrons. Okay, so let us go to part 3, but like I always tell you, don't hesitate on subscribing. Don't hesitate on referring this channel to somebody else. We believe we are the best channel in this field, and we believe you will not regret. The channel is Physical Sciences Silver Bullet, and the name behind the channel is Richard. Thanks very much. See you in the next video, part 3.